Good day, everyone. And once again, we are back together. Right, we are still preparing for that final exam in mathematics. So I thought I would just give you a plug once again on functions. So today we're going to be looking at the hyperbola rather, and then as well as the straight line function. In this case, if you haven't subscribed, please just make sure you are part of the family. And of course, your favorite uncle will continue to give you good content when it comes to maths and science. Right, let's look at the question. So we're given there that f of x is 4 over x minus 3 plus 2. Of course, that is a hyperbola, right? Just something for you to note and remember. Remember that when the value of a, rather, let me try and write that nicely. When the value of a for the hyperbola is greater than 0, which is the case here. If you look at that, we've got 4 over there. It's not negative 4. So the value of a is greater than 0. So we normally expect a hyperbola that would actually have, its graphs in the first and the third quadrant, right? So remember that if a is less than 0, you would have that hyperbola in the second and the fourth quadrant. Right, if you haven't watched this as yet, please go and look at my longer lessons or my full lessons on functions. Okay, that will help you quite a lot. Okay, right, so let's have a look at this one. They said write down the equations of the asymptotes of f. Now, please remember when it comes to the hyperbola, right? So it means that if I look at that value at the bottom there, right, the negative 3, that becomes your vertical asymptote, right? So it means that I know that it will cut through x is equal to 3, and please remember it changes sign, right? So in this case, my first asymptote would be at 3, right? So I'd say my first asymptote would be at x is equal to 3, as well as my other asymptote would be at y is equal to 2. That's my horizontal asymptote. So keep that in mind, right? Now, they say to you, determine the x-intercept of f, right? So we know at the x-intercept what happens. We know y is equal to 0, right? So to answer that, we're going to simply say, okay, so y is equal to 0. That's 5.2, okay? So our graph is f of x is 4 over x minus 3 plus 2, right? So in this case, we know at the x-intercept, this is where y is equal to 0. So we're going to equate this to 0. So what we have, 4 over x minus 3 is equal to, I'm going to take this to the other side and it becomes negative 2, okay? So in this case, we're going to have 4 is equal to negative 2 into x minus 3, right? If you want to, we can divide by negative 2 on both sides, okay? And of course, we've got x minus 3 is equal to negative 2. 4 divided by negative 2 will give us negative 2. And of course, when we take the 3 to the other side, we have x is equal to 1. So we know in this case, it means that the graph will cut at x is 1 and y 0, right? So our x-intercept, all right, will be at, that's x is equal to 1 and y 0, okay? Right, now let's go on to the next one. They also want the y-intercept. So we know for the y-intercept, x is equal to 0, okay? So it means, to answer the next question, 5.3, we take f of 0. So we know we take x is equal to 0. So this is going to be 4 over 0 minus 3, right, plus 2. So where I see x, I just put a 0 there. So that would be 4 over 3. So that will be negative 4 over 3 plus 2, okay? Now, you know that 4 over 3 in this case, that's 1.333. Or if you want to, you can just convert both of them to become fractions, right? So that will give us, let's see, so that's negative 4 over 3, okay, that's plus 2, okay, we add 2 to that and we get 2 over 3. So it means that we'll also cut now, our y-intercept will be at x is equal to 0 and y is 2 over 3. All right. Okay, so the next question, they say we should sketch the graphs of f and g. Now, before we sketch the graph of g, so also we can find as well both the y and the x-intercept. Okay, so for the graph of g, I know that g of 0 will just become 2. So if I substitute 0, remember, g of x was given as x plus 2. Okay, so g of x is equal to, okay, that's equal to x plus 2. And as a result, so g of 0 would simply be 0 plus 2, which is 2, right? So it means it will cut at 0 and 2. But also it means that for the x-intercept, okay, so we've got the y-intercept here. Okay, for the x-intercept of our straight line graph, we know that y is equal to 0. So it means x plus 2 will be equal to 0. So x will be equal to negative 2, right? So it means our graph will cut at x is negative 2 and y is 2, all right? And we know the asymptotes of our hyperbola, right? So please, I'm not going to try and draw an accurate graph, but just to give us an idea. Okay, so I'm going to start with the straight line graph. Okay, so let's say that's negative 1, negative 2. So negative 1, negative 2, and we've got 1 and 2 over there, right? So now, for my straight line, we said it cuts at x is negative 2 and y is 2. So, so for my straight line graph, in fact, maybe I should kind of use a ruler so that it just becomes easier for me, right? So you would have a straight line graph that goes across like that. Okay, right. So in this case, I know that is how we draw a straight line graph. So it would cut at 2 and negative 2. Now, for the hyperbola, remember in this case, we did say that it has the x-intercept. We found our x-intercept at x is equal to 1, right? So remember, first of all, we need to start with our asymptotes, right? So let's start with those asymptotes. We said we've got an asymptote at x is equal to 3, right? And y is equal to 2. So let's start with that, okay? X is equal to 3, right? So that's going to be our... Okay, so if you don't mind, I'm going to actually start with... okay, I'm going to just draw that in a different color, right? So for our asymptote in this case, so I'm going to have it at x is equal to 3. So that's our vertical asymptote. But I also know that I've got another asymptote at y is 2, right? So that is at y is 2. Okay, so there's my horizontal asymptote. Okay, right. So what's going to happen? In this case, I'm going to have the first part of the graph. Okay, so we know that the graph cuts through, please remember, it cuts through at x is 1 and y is 2 over 3, right? That's 2/3 in this case. So it cuts at x is equal to 1, okay? And at y is 2 over 3, so that's somewhere there. Okay, let's say 2 over 3 is somewhere there. Okay, that's 2/3 in this case. So that's where the graph is going to cut. So I'm just going to draw that in a different color. So that's the first part of our hyperbola. All right, so there's the first portion of a hyperbola. Of course, the second one would be in that quadrant there. So please remember, for the hyperbola, we did say that it does cut through, in this case, at or rather, it exists in the first and the third quadrant when our a is greater than 0. Okay, right. So I hope that makes sense. All right. So now that's what our graph looks like. And by the way, I just thought I should add this. Remember that the hyperbola also has what we call axes of symmetry, right? I'm going to draw those in a black color. So in this case, you've got two axes of symmetry. One which has a negative gradient, but it always cuts through the intersection of your asymptotes, right? And of course, you've got another one that cuts through, that has a positive gradient, and that cuts through as well, or that passes through that point of intersection of the asymptote. Just a reminder, just for you to remember. So that point there, that point there is x is equal to, we said x is 3 and y is 2. Okay, those were our asymptotes, right? Now remember, these axes of symmetry, the one has a positive gradient, so it would be y is equals to x plus c, and the other one has got a negative gradient, okay, negative x plus, well, let's just call it something else, let's say plus p, right? So in this case, to get the value of c and p respectively, what am I going to do? I'm going to substitute for that point there, the point of intersection, right, of those asymptotes. So I'm going to substitute y is 2 rather. So I'm going to substitute 2 there, and for my x I'm going to substitute 3, and I get the value of c. So it means that you would have -1, right? So it means your first axis, or rather first straight line, that is the axis of symmetry in this case, would be y is equals to x minus 1. And another one would be, again, you do the same thing. This is at 2, and where x is 3, in this case, plus p. So it means that you would have p is equal to 5. So it means that other graph would be y is equals to minus x plus 5. These are the two axes of symmetry. Please keep that in mind. All right. Now, the next question, even though they didn't ask us to calculate or to find those axes of symmetry, right? They said calculate the coordinates of the point of intersection of f and g, right? So we want where the two graphs intersect, right? So we want where f of x is going to intersect with g of x, okay? But we know our graph for f of x, that's f over x minus 3 plus 2, which is equal to, in this case, this is x plus 2, right? So let's try and solve that mathematically, right? So we've got 4 over x minus 3. I'm going to take this 2 to the other side. This will be equal to x, okay? I'm sure you can already see how that will become 2 minus 2, which will give us 0. So that will just become x on the other side. Now, of course, we cross multiply. In this case, when we cross multiply, we've got x into x minus 3 is equal to 4 times 1, which will give us 4. And so we've got x squared minus 3x. Okay, we take this to the other side, it becomes minus 4, which is equal to 0. And so we know that this is going to be x factors of 4, such that when I subtract them, will give me 3. That will be 4 and 1. Okay, And in this case, we know that the negative 4 will be, okay, that will be negative 4. And so that should be positive 1. Okay, so intersection will be at x is equal to 4 or x is equal to negative 1, right? Now, did they say coordinates there? Okay, they said calculate the coordinates of the points of intersection of f and g. So we were looking for the coordinates. So what am I going to do to find the y? I'm going to substitute x is equal to 4 and x is minus 1 into one of the equations. I'm going to substitute it into the straight line equation because that's much simpler, right? So g of 4 is going to be, well, remember I substitute 4 for x. So that's going to be 4 plus 2. That will give me 6, okay? So my first point of intersection, that will be 4 and 6. And another one will be at negative 1. So I'm going to say g of negative 1. That's going to be negative 1 plus 2, which will give me 1. And in that case, it means it will be at negative 1 and 1. Okay, that's where the two graphs actually intersect. Okay, right. So the 1 was over there. Okay, and by the way, it does show there, right? And another one will be, obviously, if we try to stretch this point, it will be somewhere there where they intersect. So that will be the second point, which is 4 and 6. Right. Now, let's get to the next question. They say to us, they say if x is greater than 3, okay, so it means we're looking on the other side of the vertical asymptote, right? They say determine the values of x for which, that value 4 over x minus 3, okay, plus 2 is less than x plus 2, okay? Now, I want you to please note in this case, right, that this is the graph for f of x, and that's the graph for g of x. So what are they saying? They want the values of x where f of x is less than g of x. So it means I'm looking for the values of x where the hyperbola is less than, which means where the y values are below the y values of the straight line graph, right? And remember, they said where x is greater than 3, right? So it means I'm going to go to my graph and say, well, there's my point where x is greater than 3. So I'm going to look beyond there, right? So in this case, you would agree with me. So from that point of intersection there, so you would have this, and there's your straight line graph going all the way, right? Where is the, they said f of x less than, right? They said f of x less than, yes. So it means I'm looking for the hyperbola being below, right, the straight line graph. And it's from that point there, the point of intersection, all the way up until infinity, the straight line is above the hyperbola. Or you can put it this way, the hyperbola is below the straight line. So in this case, our point of intersection that is greater than 3, that is from 4 in this case. So it means that we'll say x is an element of 4, right? They said less than, not less than or equal to, so we're going to exclude 4 in this case all the way up until infinity. Or you can say x is greater than 4. Okay, right. I hope that makes sense, ladies and gents. So this is for all values of x that are greater than 4. All right. Okay, and the last point, they say the line y is equal to x minus 1. Okay, cuts f at p, which is 1 and 0, and q. They say write down the coordinates of q. Okay, so now it means that we have another straight line that will obviously intersect with f, right? So we're expecting that that straight line will actually intersect at f with f at 1 and 0, okay, as they did say there. So we want where f in this case, which is 4 over x minus 3 plus 2, right, will be equal to the line x minus 1. Okay, right, so let's try and solve for that. So we're going to have 4 over x minus 3, okay, and I'm going to take the 2 to the other side. This will be x minus 3, right? Please, I just want to make sure that I've written that correctly. Okay, yes, I did. So in this case, I'm going to cross multiply once again. So I'm going to have x minus 3 squared. Can you see we've got x minus 3, which is equal to 4, right? So x minus 3, so take the square root on both sides. That's plus or minus right there. So x minus 3 is equal to plus or minus 2. So we've got x is equal to, okay, so x minus 3 rather is equal to positive 2, or x minus 3 is equal to negative 2. So I've got x is equal to 5, okay? And of course, the other one, I'm expecting that value 1 and 0, which was called p, right? So in this case, that's not the one that we are focusing on. So in this case, we are looking for x is equal to 5. Now, how am I going to get the y value? Right, I'm going to substitute it in the equation of the other graph, x minus 1. So y would be equal to 5 minus 1, which is equal to 4. So the point Q will actually be equal to, in this case, where x is equal to 5 and y is 4. All right, ladies and gents, I hope that you were able to follow on that question. Of course, I did say that functions, by the way, carry the most marks when it comes to mathematics. So just make sure that you can master those. Otherwise, from me for now, I'll see you guys later with more questions on geometry. Sharp, sharp.